Okay, so part 2 here of lesson 7.4 talks about using half angle formulas to find exact values. So this one tells me I'm dealing with cosine of 165. So if I think about where that is on a graph, 165 degrees is going to be over here in quadrant 2. So when I think about that, I'm thinking, okay, I've got my x values are negative, my y values are positive, which means my cosine values are negative. So I know that I'm dealing with negatives, and why is that important? Because when I'm dealing with my half angle formulas, remember those were plus or minus situations. So I need to make sure I know which one it's going to be. Is it positive or is it negative? So in this case, cosine is going to be negative. So I know that I'm dealing with that, but then I have to think about what this even looks like as a half angle. So like, what half is it? So if I have 165, if I take 330 and divide it by 2, I get 165. If you don't know that just off the top of your head, you can take 165 times 2, and that's your top number. Okay. So then I can use my half angle formula. So I know I'm going to deal, I'll put plus minus, but I know I'm going to be dealing with the negative in this case. And then here's that formula again. It is 1 plus cosine over 2. So 1 plus cosine of my theta value, which in this case is 330. That's why that's important to get that, all over 2. So that means I've got negative square root of 1 plus, what is the cosine of 330? You can use your unit circle to find that. So 330 cosine would be square root of 3 over 2. It's kind of messy, all over 2. Sorry that this is so tiny. Try to make sure it's nice and clear. Okay, so then let's try to simplify this. So I'm going to take my top and bottom times 2. So remember, we always try to rationalize that denominator. So this is the square root of 2. So if I take the square root of 4, that's going to come out better. So this is going to be negative square root of 2 minus, this would give me just the square root of 3 in there, all over 4. And if I square root the top and the bottom, that gives me negative square root, this should be a plus, sorry, of 2 plus the square root of 3 all over 2, because the square root of 4 is just 2. Another way that you could write that, they may do this in the back of the book, so I want to point it out. You could have said this is negative 1/2, and then put that square root of 2 plus the square root of 3 kind of off to the side. Either of those are okay answers. Okay, my second one, I've got the sine of 157 degrees 30 minutes. So I want you to think about that for a second. Instead of minutes and degrees, I want you to think about it as 157.5 degrees. Again, I'm going to kind of picture where is that. 157.5 would still be over here in this quadrant. So again, I've got a negative, positive coordinate point. So this is my x value is negative, my y value is positive. So my sign in this case would be positive. So I'm thinking about that. The other thing I'm thinking about is how can I make this a half angle, right? So I'm thinking what divided by 2 would give me 157.5? That would be 315. Okay, so then I'm going to go through my formula here. I know that when I'm thinking plus minus in this formula, in this case, I'm only really thinking about the positive because the sign value is positive in this case. So I'm really thinking positive. And then my formula is the square root of 1 minus cosine of 315 in this case, all over 2. Okay, so then that's going to give me positive, which I don't really have to put that, 1 minus cosine of 315. So now I'm going back to my unit circle again. 315 is right here. My cosine value on that is square root of 2 over 2. So I've got 1 minus the square root of 3, square root of 2, sorry. Square root of 2 over 2, getting ahead of myself here, all over 2. Again, I'm going to multiply by 2 over 2, try to get this to look prettier down here. So that's going to give me the square root. I'm going to leave just the top square root. So this would be 2 minus the square root of 2. All over this bottom would be the square root of 4, or just 2. So this is one way of writing the answer. Or, again, I could write it as positive 1/2 in this case, and then square root of 2 minus the square root of 2. Lots of square roots in these. All right, the last one is asking me about tangent of pi over 8. Don't overcomplicate these, so I can write it as a half by making it pi over 4, because if I take 4 and then I divide it by a 2 also, I end up dividing by 8 overall. So you can write it like that. Okay, so that means my theta value is pi over 4 this time. And again, if I'm talking about tangent, that gives me 1 minus cosine over sine. So 1 minus the cosine, again, you're using pi over 4 as your theta value, over sine of pi over 4. All right, so then again, you can use your unit circle to find your cosine and your sine of pi over 4. They are the same, square root of 2 over 2. So that gives me 1 minus the square root of 2 over 2, all over the square root of 2 over 2. Now, one easy way to get rid of all these fractions within fractions, again, would be let's just multiply by 2 over 2. Because if I take this times 2, that'll cancel. And if I take this times 2, that denominator will cancel also. Just don't forget to take your front times it. So I've got 2 minus the square root of 2 all over the square root of 2. But again, I don't like having square roots. So now I'm going to take it times the square root of 2 over the square root of 2. So that means I have 2 square root 2 minus 2 square root of 2 times the square root of 2 is the square root of 4, which is 2, all over, again, same thing, is going to give me 2. So then I can simplify this. That's really the square root of 2 minus 1 if I divide each of those by 2. So there's really only one way to write that one. All right. Example 5, they want me to verify. So this is where I'm trying to get one side to look like the other, but this time I'm going to use these new formulas that we've gotten. So on this first one, I'm seeing a cosine squared and a sine squared. So when I look back over here, I'm seeing a cosine squared and a sine squared. So that's really cosine of 2, whatever this, 2 times whatever that is. So this is actually the same thing as saying cosine of 2 times whatever that theta value was in this case, or u if you want, I don't know why I put a 2, or that u value in our formulas. So it's really cosine of 2 times 3x. That's what that side is. And then this side was cosine of 6x, and that just happens to be the same. Cosine of 6x equals cosine of 6x. That's verified. Part B is a little more complicated. So this one, I'm seeing a sine squared of 2 times something. So I'm thinking if I've got a 2, this is like a double angle right here. So I'm looking for that sine of a double angle. Really that sine of 2, in this case alpha, is really 2 sine of alpha cosine of alpha. So I'm just going to replace this with 2 sine of alpha cosine of alpha, but that is squared in this case because it's sine squared of that. The bottom was sine squared. I'm just going to leave that for a second. Leave that side exactly the same. So now I'm going to actually square this out. So if you square this is all multiplication in here, you really can just square each of these things. So this is 4 sine squared cosine, that's squared, all over sine squared. Okay, so in that case, this cancels. So I end up with 4 cosine squared equals 4 minus 4 sine of alpha, which still isn't great, but I want to remind you that cosine squared, so let's go back over here. Cosine squared, I'm going to use this right here. So remember, when I had sine squared or cosine squared, I could rewrite that. So let's say I'm talking about cosine. Cosine is the same thing as 1 minus sine squared. Cosine squared is the same thing as 1 minus sine squared. So in this case, I'm talking about cosine squared right here. I'm going to rewrite this piece as 1 minus sine squared. And a lot of people are like, why would you do that? Well, let me show you. If I rewrite it like this and there's a 4 up front, I can distribute that and it looks like this. So I was looking for something that would relate my cosine with my sine when I have some kind of subtraction here. So I was just thinking, well, if I factor out a 4, that would be 1 minus sine. So here I have a 4, 1 minus sine squared. I forgot my sine squared up here all the way. That makes sense now. Okay, so this is the same thing as this, and I can show that final step of distributing, and then that makes more sense. Okay, so that is the same then. Okay, the last example here says find the solutions of the equation that are in the interval 0 to 2 pi. So I only have to think about from 0 to 2 pi, and then they're giving me this equation. So in that case, I'm just throwing this out there, it is easiest if you can transform one of these and then factor something out. That's what I really hope that you do on all of these types of problems. So try to see what you're given, transform it using those either the double angle or half angle formulas, and then factor. So in here, I'm seeing a double angle right here. Sine of 2t. So in this case, sine of 2t would be 2 sine of t cosine of t. So this right here is the same thing as 2 sine of t cosine of t. So I'm just going to fill everything else in. So I transformed this into this. Then these both have both of these terms. There's one term, here's the other. They both have cosine in them. So I'm just going to take out, I'm going to factor out a cosine, which leaves me with a 1 minus 2 sine. So I took cosine out of both of them. Then I can say, okay, if these equal 0, so get them to equal 0 first. Then once they equal 0, then you can factor it and set them equal to 0. So the cosine of t equals 0, and 1 minus 2 sine of t equals 0. So first I'm looking for when does cosine equal 0? So let's go back over here. Cosine is your x value. When is x 0? Pi over 2 and 3 pi over 2 is where that happens. So pi over 2 and 3 pi over 2. That's definitely 2 answers. This one, where does that happen? I'm going to go ahead and solve that out. So when does the sine of t equal 1/2? So back over here, when does sine equal 1/2? Well, that happens at pi over 6 and at 5 pi over 6. So pi over 6 and 5 pi over 6. So there's your 4 answers in this case, and I only have to think about from 0 to 2 pi, so I only have to think about my unit circle. Where is that happening?